Hello friends, welcome back to today's class. So in the previous class we have went through the various things, like to name a few things. We have finished your mapping techniques. Okay, we have seen what is mapping, how to do the various mapping techniques, like say for example set associative mapping, directive mapping, associative mapping. All those things have been covered in the previous class. To move ahead with the new chapter and a new thing in today's class, we will be discussing regarding your memory system. So in that memory system, today we'll try to look upon your virtual memory. Okay. So let us begin. So virtual memories. If you remember, the major challenge when we design our computer system was to give a very speed memory. But we had some trade-offs. Like say for example, if I want a speed memory, then it would be small. If I want a large memory, then it would be slow. And if I want both speed and small, then the cost would be more. So therefore this was a major issue, that we should get all the things, like say for example speed, less cost and higher space. So you got it. So therefore these three together to get was very difficult. And you already know that the main memory is very small compared to the address space which is generated by the processor. So to make it more understandable, this statement, that is the main memory is small when we try to compare it with the address space. Let us take a simple example. Say you have a processor and this processor has 32-bit addresses. Then the address space would be how much now? It is 2 raised to 32. Okay. So what I'm trying to tell is, say for example, you have a processor and which is 32 bits. It is 32 bits. That is, the address lines are 32 bits. Then the address space will be what now? It is 2 raised to 32. 2 raised to 32, which would give you somewhere around 4 GB. This would give you somewhere around 4 GB. So therefore you can observe that the size of the memory is of the order of megabytes. Therefore the large problem or the bigger problem here is we may not be able to completely fit this into the main memory. So therefore what we did, we started writing the programs in the form of parts, so that we would take only that part of the program which we would like to execute, and the rest of the program we would keep it in the storage devices, like say for example your hard disk or any secondary storage device. Okay, that means what was happening now? Here you can observe that so what we are seeing, like say for example we have a larger program, then we would not completely put the whole program into the main memory. We would take a part of a program, we would execute it, and the rest of the programs we used to keep it in the secondary storage device. So this is how we used to do it. Okay, that means we required some solutions so that the effectiveness of the speed and the size of the memory has to be increased. That is, we should try to get both the trade-offs in one section. So we want to increase the speed as well as size of the memory system. So in order to do this, we came across a small change which we called as what? You already know it. It is nothing but your cache memory. Then we came across a new technique called as cache memory. What was the use of this cache memory now? The use of cache memory was nothing but every time whenever I want to execute anything, it was not necessary to go to the secondary space. A part of a program was always available in the primary memory space, that is near the processor. Thereby what happened? The speed of execution was increased. I hope you remember this. Cache memories has been already covered and you know how it is useful. But friends, even cache memory was not that effective. It is effective, no doubt in that, but in order to further enhance the whole functionalities, we came across a new solution called as virtual memory. So virtual memory is one such solution which would increase the effective size of the memory system. So once you have virtual memory, it could be very useful. So that means how it is useful now, to make you understand. Let us say I want a new segment of the program which is to be moved into the main memory. Then what is the main problem we occur here? What is the main problem? Like, I hope you are understanding. You have a processor, right? Near this you have a cache wherein you have put a part of a program in this cache. The major program is where now? The major program is in the secondary device, right? So what do? You put a part of a program into this cache, you execute it. Now again, if I want to put a new part of the program into this cache, what you need to do? You need to erase this previous program. Whatever the previous program was there, whatever the previous I had drawn just now, so whatever the previous thing was there, that has to be removed. So therefore this was done by whom now? This was done by the operating system. Thereby what was happening is, application program was not able to control your physical memory space. Therefore the application programmer visualizes the memory as a large storage which is available, where all his programs can reside without being constrained by the physical memory. That means what your application program is trying to guess now, he is trying to feel that all the program is available into his own memory. Thereby he is trying to visualize it. It's not actually available, but he is trying to visualize it. This leads to your technique, to a solution called as virtual memory. That means what virtual memory is doing now? Virtual memory is nothing but it is trying to recall, or it is trying to regenerate your illusion. It is just creating an illusion so that the processor will feel that all the program is available in the main memory itself. Okay, so just observe this point here, friends. Large programs cannot fit completely into the main memory. So you can observe here. So large programs cannot fit completely into the main memory. Thereby what we did? We started having their parts stored on the secondary storage devices such as magnetic devices. Thereby what we did? We took a piece of programs and that transferred to the main memory from secondary storage before getting executed. This is what I tried to explain till now. Okay, so I hope so this point is clear now. So this whole thing was automatically done. This also has been explained by the processor. Okay, now whatever the addresses are getting generated now, these are very important. So therefore the program or the processor, what it will do is, it will refer to the instructions or data space which is independent of the available main memory. Whatever the main memory is there, that should be independent of the instructions. That means the binary addresses here are called as logical or virtual addresses. So this is very important point to be noted. Whatever the binary addresses which are getting generated, these are called as your logical or virtual addresses. Okay, so the processor which is trying to issue these binary addresses, for what it is issuing now? These binary addresses are issued for instructions and data, with the help of which we will be trying to get your virtual addresses. Okay, so this whole part is clear, I guess. Moving ahead, the next very important thing is, okay, how these addresses are converted, how the logical addresses are converted into physical addresses. So the very important thing which needs to be done here is, we are creating the logical addresses. Try to concentrate here, friends. We are creating a logical addresses. Yes, we are creating logical addresses. Then this logical addresses has to be converted into what now? This has to be converted into physical addresses. Right? This has to be converted into physical addresses. So this is very important point, friends. So if I want to do this, if I am able to do this, then I am done with most of my work. Okay, so who is doing this then? This is done with the help of a hardware or software approach. Any one of the approach would be used to do this, either the software approach or the hardware approach. So whatever you can see now in this figure, that is the below figure, what you can see right now, it shows the organization of your virtual memory. It tells us how the virtual memory is totally designed. So here, if you can observe, friends, this is very similar to the previous diagram which you have already seen, but there is one small unit which we have added. What is that small unit? I try to make it dark, so if we can observe it, that small unit is nothing but your MMU. So this is my small unit, which stands for memory management unit. So this is a special hardware unit called as memory management unit, using which we will be trying to do your virtual memory. So what this MMU does now? This MMU is nothing but it will try to convert your virtual addresses into physical addresses. So I hope you are getting it. We have our virtual addresses. What are the virtual addresses, friends? Virtual addresses are nothing but your logical addresses. We have the logical addresses which we are created so that we would get your virtual memory. Then these logical addresses has to be converted into what now? Your physical addresses. Who is doing this conversion? This conversion is done with the help of an unit, special hardware unit called as, it is called as, anybody? It is called as MMU. It is called as MMU, which stands for memory management unit. Okay, you can observe here we have the virtual addresses. These virtual addresses are fed into MMU, that is memory management unit. What the memory management unit will do? It will convert it back into physical addresses. So this MMU causes the operating system to bring the data into the main memory from the disk. Whatever the data is there in the main memory, that will be brought from the main memory, from the disk into the main memory. So this also does that thing. So therefore the data transfer between the main memory and the disk is carried out using the DMA technique. I hope you already studied this DMA technique. Okay, DMA stands for direct memory access. D stands for direct, this is memory, direct memory access. Okay, so this has been already covered in your previous chapters. Okay, so try to have a look at the DMA technique. Okay, so these are the few very important things which your MMU does. First thing, what is the first thing it does? It translates your virtual address into physical addresses. Next thing is what? It will try to fetch the data as described from our previous techniques. Next, if the desired data or instructions are not available in the main memory, then they are transferred from the secondary storage into the main memory. Okay, so this is another very important thing, that is from the secondary storage devices. Who is going to do all the transfers? It has been done by your MMU. Okay, that is secondary storage is nothing but your disk or your tape, something like that. Okay, then next thing is what now? It also causes the data to bring from the what it is causing? The operating system. It will tell the operating system to bring the data from the secondary storage into the main memory. So these are the few very important things which your MMU is trying to do. And all these things have been depicted in this whole diagram. Okay, you can observe here, you have a processor, you have a data, in between you have a MMU, then you have a cache, main memory and the disk storage. You can observe a double arrow in between your disk storage and the main memory. That means the data is being transferred or is being exchanged in between your main memory and disk storage. So this is very important, friends, virtual memory organization. Many times they have asked this in the examination as well. Please try to study it very carefully. Okay. So here I will be stopping the today's class. That is this video. You can just have a look at whatever has been studied today. Very important things have been covered in today's class. Okay, so please have a look at this. And one more major request for you guys is, please have a look at the previous videos. Don't directly jump to this video because many of the important things have been covered. Try to do it a bit carefully. Okay, thank you for watching. We'll again meet in the next class.